Welcome back. So for the next couple lessons, we're going to be taking a break from linear things. Instead, we're going to focus on transformations. Because transforming functions is going to be a key thing in graphing all throughout the rest of Algebra 2. So what I've done is I've actually provided a couple graphs for you. All right, so this graph right here is y equals x squared. And then on this side, I've graphed y equals x squared plus 3. And I want you to notice, what is that plus 3 doing? Okay, if we look at the differences in these graphs, I think you can hopefully see the graphs are the same, except it's been pushed up by 3. So what we would say is how they're related is translated 3 up. Okay, the graph on the right is just a translation. It's being moved 3 up from the graph on the left, that parent function y equals x squared. Now let's take a look at this next one. So this one is y equals x squared minus 4. So we want to relate this back to the graph of y equals x squared, so that graph that you saw on the left. And if you notice again, it's basically the same graph, but this time notice it's being shifted 4 down. So that minus 4 right there is translating it 4 down. So hopefully you can see a pattern that when you have the parent function and you're just adding or subtracting from it at the end, basically all that's happening is you're moving the graph up or down. So what is this plus 6 doing? Well, it's going to translate it 6 up, okay? So that's pretty basic. Most students don't have any issues with the translating up and down, all right? But let's take a look at another one where we're translating to the left and right. So here's the function y equals absolute value of x. You're going to get a little refresher on graphing that in a couple of lessons from now. And this is y equals absolute value of x plus 2. Now, the thing I want you to notice, that plus 2 that's in there, remember, when it's inside the function itself, when it's affecting the x, remember it's affecting it oppositely, right? So remember that is actually translating 2 to the left. Right, that's what we would reference that as. And this next one, what is that minus 1 doing? Well, again, it's kind of doing the opposite of what you'd expect, is it's translating it 1 to the right. So remember, if the translation is happening inside the function itself, remember it's acting oppositely the way you'd expect, and it's translating it to the left or to the right. Now, without a graph, now you should be able to determine what is that minus 7 doing in there. Well, remember, that's going to shift it left or right because it's inside the function itself, and that always acts oppositely what we'd think. So this would be a translation. It's translated 7 to the right. Okay, on the inside there, negative means push it right, positive means push it left. And then, of course, then we can also actually do combinations of these. So notice here, we have two things happening, okay? In green, notice what's happening to the function, okay? It's translated to left, and notice what happened in blue. translated 1 up. So as we get good at these combinations, you can actually put things together. You can have multiple translations at one time. So why am I showing you all of this? Well, because there's two things that I want you good at, okay? The two things I want you good at are, can you describe transformations to me, and can you write functions based on transformations? Those are kind of the two biggies that I need you to walk away with. So what I would like you to do is now let's interpret this. So here I have two things happening. That plus 3, that is inside my function. So that's going to translate it 3 left, because that's always opposite what you'd expect, and then translate 1 down. So what that would look like is taking every one of the points on that graph, translating it 3 left, 1 down. So I took that point, moved it there. Let's move this point. 3 left, 1 down. Let's focus on this point. 3 left, 3, 1 down. Let's focus on that point. 3 left, 1 down. And this point right here. 3 left, 1 down. So I've taken every one of those points and shifted it. So now your new graph, this graph, would look like that. Okay, so you can actually shift graphs using these transformations. All right, now let's take a look at this. All right, and here I apologize, this actually is not in your packet because that is actually not the right graph. So just ignore that that's there on my version because I know that it's not in yours. So here, if I want to describe those transformations, right there, when it's on the inside of the function, that's going to translate to right. And that is going to translate it 3 up. All right, so again, all you have to be able to do for me is that's kind of the key here. Can you recognize those transformations for me? And looking at this, so writing a function based on its transformations. So I want to write a transformation left 3 units. Well, left 3 units, remember, means it's inside the square. It's inside the function, right? So, and again, it acts oppositely what you'd think. And then you also want to move it 3 units up. And of course, if we're looking at the graph, we can actually do that. I could take this point and move it 3 left, 3 up to put it right there. I could take this point, 3 left, 3 up to put it right there. I could take this point, 3 left, 3 up, put it right there. I could take this point, 3 left, 3 up to put right there. I could take that point, 3 left, 3 up, put it right there. And this is what that function would actually end up looking like. Okay, you can see it actually shifting 3 to the left and 3 up. And again, this last one, I apologize, that is not in yours because again, that's not the right graph. So let's just focus on now dealing with the absolute value function, all right? So this time I'm dealing with an absolute value. Shifting to the right is going to happen within that function, all right? So within the absolute value function, 1 to the right, again, has the opposite shift that you'd expect. And then down 1 would look like that. So if you can leave here knowing how to describe those transformations and how to write me functions of the transformations, then you are in good shape. So once you're done with these, please make sure that you have everything filled out, and then you can begin working on your practice work.